Question 14 in chapter 6.1. It's a great little question to get you thinking about different polygons. So you have to find the angle, the size of the angles alpha, beta, and theta. So first of all, you have to study your shapes. So this one here is an 8-sided shape. So as per usual, if you get a chance to draw around, mess around with stuff like this, please do. So working out the angles for a hexagon, that should be the center. It's not quite the center, but you get the idea. You get all these triangles. And because we've got 1, 2, 3, 4, 5, 6, 7, 8 angles here in the middle, each one of these is going to be 360 degrees divided by 8, which gives you 45 degrees. And each one of these is an isosceles triangle, which means this angle in here and this angle in here is equal, and that's 67.5 degrees. So I'll just draw each triangle that we'll be dealing with as we go through here. Got a triangle here. It's 45, 67.5. Make that a bit better. Okay, so you get the idea. So if this here is 67.5, this here is 67.5, and this here we know to be 90. So to work out this angle here, we have to take those away from 360. So alpha is going to be equal to 360 minus 67.5, and 67.5 is 135. Also minus your 90. So alpha is equal to 135 degrees. Okay, moving on to your next shape. We'll move on to the square is a square. That's pretty obvious. We'll come to that in a second. But we'll move on to the hexagon over here on the right hand side, and we repeat the process that we've just done there. This would be, if we were to divide it up, you would be getting 6 angles here, which means each one of these is 60. This is a little bit special then, because if this is 60, these here are also 60, these triangles. So that triangle is one that's 60 and 60 and 60, which means it's equilateral. So you're trying to find the angle theta. Well, you know that that's 60 and that's 60. Everything up there is 60. So straight off the bat, you can work out that theta is going to be equal to 60 and 60. That's 120 degrees. Which brings us over here to look at what beta might be. Well, if that is 60 and that is 60 and that is 90, beta, just stick it in here, beta is going to be 360 minus 90, which is 270. It's minus your 90, and then it's minus 60 and 60, which is 120. So you're getting beta equal to 150. So that's the angles done. Moving on to the areas. Now you're told that the square has a side of 4 centimeters. So that and that and that are 4. So the area of the square is equal to 4 squared, which is 16. The area of the, we'll work over here with this hexagon first of all. So the area of the hexagon is going to be 6 times each one of these triangles. So how do you find the area of one of those triangles? probably the quickest way would be to say half AB. Now, because this is 4 and these are all equilateral, we all know that these have to be 4, 4 and 4. So it's a half AB sine C. That's a sine of 60 degrees. So go to your calculator, and it's 6 because there's 6 of them. So half AB sine C is area 1 triangle, and we have to multiply it by 6. So 6 multiplied by a half AB being 4, multiplied by 4, then multiplied by your sine 60. And you're getting 41.569 with 24 times the square root of 3. So whichever format you want to keep it in, you're asked to do correct at 1 decimal place, so that would be enough for you. And that just leaves us with our last shape over here, this 8-sided shape, this 8-sided polygon. Now, find the area of the octagon. You need to find the area of each triangle again. So it's going to be 8 times the area of one of the triangles. Okay, that's the first thing. So this is the triangle that we have to look at. Now there's 2 ways of going about doing this. One, I'm just going to rub that out and use it again. So up here was 45, and this was 67.5. Now if you were to split that right down, you would have 2 and 2, and using your junior sort of trigonometry, you could work out what the perpendicular height is. So that would just be tan 67.5 is equal to the opposite over the adjacent. So in other words, 2 times tan 67.5 is equal to our perpendicular height. So that's probably the quickest way to do it. You could of course use the cosine rule either to work out the area of one of those triangles by finding the length, but that's probably the quickest way to go about doing this would be just stick to your junior cert trigonometry. So it's going to be 8 times the area of the triangle, and each triangle is going to be half the base. So our base is we know that these bases here are 4 by the perpendicular height, and we just worked out the perpendicular height to be that there. Half the base by the perpendicular height, which is 2 times tan 67.5. And that there is going to give you the area of the octagon. So stick that into your calculator, and you're getting 77.25. So 77.25 plus 41.5692 plus your 16. That's giving you an area of 134.81. It's all in centimeters squared. To 1 decimal place, that's going to be 134.8 centimeters squared.